Well, good morning, everybody. We're going to start our second wave of Zoom meetings for a Great Montana Ag Rally. I'd like to thank you all for participating in this morning. This is a great series of 1-hour educational workshops to help our membership continue to stay informed and up to speed on the latest technology and information. My name is Dan Bratton, and I currently work for Helena Agri Enterprises. I've had experience with CHS and also the independent side as well. I've been on the board since 2016. I also want to say thank you to BASF for their support of the rally and sponsoring this session. We're going to start with a short video from our sponsor, BASF.
Hello, and welcome to this session from BASF. My name is Paul Clemmy. I'm the product manager for inoculants and biologicals with BASF Seed Treatment. I grew up on a farm in central Iowa where my family still farms, and I've been in the agriculture business my whole career. The last 12 years, I've been in the inoculant industry in sales, marketing, business development, and product management. I joined BASF because of some of the great new innovation that we're bringing to market, especially in the inoculant space. What I'd like to do for the next few minutes during this session is talk to you about one of those new innovations, Nodulator Duo Solid Core Granule Inoculant for peas and lentils. One of the things that we'd like to provide as a gift to you is this tumbler for attending this session, as well as learning more about Nodulator Duo Solid Core Granule Inoculant. So all you have to do is email your name, address, city, state, and zip to the Montana Ag Business Association email here. While you're doing that, I'll play one of the ads that we have running on your local radio stations talking about one of the great benefits that Nodulator Duo brings your growers.
Yeah, so I use new Nodulator Duo Solid Core Granular Inoculant on my peas and lentils.
This guy, he's full of seeds.
Stop it. 3 more bushels per acre.
Ha! You're full of seeds, pal.
Well, yeah, my crops had better nutrient uptake and a root strengthening biofilm.
You're full of seeds.
Right, I know. I had bigger and fuller pods.
Huh. You really are full of seeds. Full of seeds. Try Nodulator Duo SCG by BASF for bigger, better yields. BASF, we create chemistry. Always reading follow label directions.
Hopefully you enjoyed that ad and we'll look forward to hearing that on your radio stations. As I mentioned, Nodulator Duo is brand new for 2021. It has been available in Canada for the last 3 years, and we're excited to bring it to the US. Nodulator Duo has 3 unique features for your pulse growers. This technologically advanced solid core granule that I'll talk about a little more in the next slide. The high-performing rhizobia strain specific for peas and lentils. And then thirdly, this new plant growth-promoting rhizobacteria, Bacillus subtilis, that brings some great nutrient uptake as well as plant growth development that you can get in Nodulator Duo. So the granule, solid core granule, is the first thing that I'll talk about. Here on the slide, you can see we have a clay-based hard granule surrounded by layers of the rhizobia, the bacteria, as well as some polymers and overcoat protection to allow that rhizobia to survive and then thrive once it does get into the soil. It is engineered to deliver the product through your air carts, through your seeders. It's durable, uniform in size. And you can see here in this picture, the peat products that a lot of competitive products may be utilizing as a base sometimes can have some dust or have some flowability issues. With solid core granule, you should not have those issues and can have some great improvement when it's flowing through your customer's equipment. The second key thing with Nodulator Duo is this rhizobia strain. It's specific for peas and lentils. It was developed in Canada, and we see increased nodulation, increased nitrogen fixation. This picture here on the bottom shows a competitive inoculant versus the BASF strain where you've got nodules throughout the root structure as well as a larger root mass. The third and the duo part of Nodulator Duo is this new bacillus. This bacillus provides or forms a biofilm on the root. Here you can see a water control on a petri dish versus the right-hand side where the biofilm is. What this biofilm does is it allows the plant to uptake water and nutrients more readily. It helps mitigate abiotic stress, and it improves that relationship between the rhizobia, the bacteria for nodulation, nitrogen fixation, and the plant. The result is you get higher yields. When you look at this plant growth, Here's a slide that talks about some of that enhanced plant growth. The blue bar is Nodulator Duo solid core granule, and the dark bars are competitive products or the old formulation of Nodulator. Early season results, mid-season results, significant differences in plant growth above ground as well as below ground, as you can see in the picture on the right-hand side. Of course, yields is what pays the bills. And as the radio ad talked about, we see about a 2 to 3 bushel yield response with Nodulator Duo solid core granule. Nodulator being in the blue, competitive products, whether it be a base, low rhizobia, or what's considered somewhat of a premium product, we see a significant yield response with Nodulator Duo. Again, more nodules, greater root structure, all adds up to more yield. Next, what I'd like to do is play a short video that talks about or shows the biofilm as I talk about it. Again, this root strengthening biofilm really improves nodulation as well as the ability of key plants to be able to take up nutrients and expand their ability in the soil to utilize the water as well as nutrients that exist in the soil. You can nodulation throughout the biofilm, expanding the reach of those roots. The next couple slides, I'll talk about our portfolio and some inoculant handling best practices. We have a complete portfolio for pulses as well as chickpeas. Nodulator Duo solid core granule, as I just talked about. We've got a couple package sizes, 850-pound tote bag. Granule, the old formulation of Nodulator, liquid as well as peat. For chickpeas, we have a dedicated strain for the chickpea clay granule. So if you've got growers that are utilizing chickpea, make sure that you've got the right granule for them. Again, same package sizes as the Nodulator Duo for peas and lentils. When it comes to grower efficiency, the Nodulator Duo brings some great advantages here for your growers. If you're on a 7-inch row spacing, 4.7 pound application rate, a grower can cover 170 acres per that tote. If they're on a 10-inch spacing, 245 acres at 3.3 pounds, which is significantly less than some of our competitors that are in that 5 to 6 pound range. The last couple slides talk about the importance of handling inoculants properly compared to chemical products. They are living organisms, and so you just need to handle them a little bit differently. Proper storage and handling are key to make sure that you get the performance that you want. BASF does have the highest standards for all of our inoculants and recommend that you do handle them as per recommendations. And one of those recommendations is to make sure that the products don't freeze. The granule formulation is the hardiest and can handle exposure to hot and cold conditions, but it's important to not let it freeze. We do recommend that you store it in dry conditions with good air circulation and only stack the pallets one high. The last slide I'll talk about is BASF's commitment to quality. We've got quality products. We've significantly improved our manufacturing capabilities to deliver products where and when they're needed. We've got the ability to meet market demand, and we're always looking to adapt, invest, and improve our biological products. Nodulator Duo solid core granule is one of those new innovations that we hope that you'll like. And with that, I encourage you again to send an email to the Montana Ag Business Association to receive your free tumbler. Listen for the radio ad that's playing, and also encourage you to reach out to your BASF representative to learn more about Nodulator Duo. Enjoy the rest of the sessions, and we look forward to working with you throughout the next few years, bringing innovation to the inoculant space.
I had bigger and fuller pots.
Huh. You really are full of seeds. Full of seeds. Try Nodulator Duo SCG by BASF. Bigger, better yields. BASF, we create chemistry. Always read and follow label directions.
Enjoy the rest of your sessions. Thanks again for attending.
Well, thank you, BASF, for that update. Now I'd like to introduce our speaker today, who is Ryan Helmer. He is the National Field Technology Manager for WilburEllis Company. Over the last 5 years, he has been working with growers in Montana and across the Northern Plains to bring cutting-edge technology to their farms. And his primary focus is helping them build and maintain profitable, efficient, and a sustainable production and agriculture business plan. Thank you, Ryan. Please take over.
All right, good morning. And once again, thank you, BSF, for sponsoring today's session, Interact F4. I'm Ryan Helmer, Field Technology Manager for WilburEllis Company. Today, we're going to discuss ag technology, and more specifically, some of the practices that I've found and I think the industry has found to be effective here in Montana and the Northern Plains. So first, we will take a look at where we've been. So, field technology evolution. I know some of you guys might like to tell stories from some of these days of these technologies on the top row, but we all know none of us were truly there. So, early 1800s, John Deere and amongst others grabs a hold of the invention of the steel plowshare. And that's really probably one of the first big advances in farm technology. For thousands of years, there were little to no changes within agriculture. Everything was done with hand tools and wooden tools, hand labor, limited animal labor. So about 200 years ago, the steel plowshare really took hold. And within another 100 years, the internal combustion engine here, this middle row, this is one of the early combines that was invented for the California wheat rush. Previous to this, harvesting, so cutting the grain and threshing the grain were two separate activities. So the combine was really a major step forward, and this was really due to the lack of labor. So this particular photo, this is a machine that was powered by an internal combustion engine and pulled by up to 40 horses. Then, of course, by the early 1900s, small tractors with gasoline engines and previously some steam power was starting to become commonplace in replacing animal agriculture. So fast forward to the 2000s, this picture here in the lower left is a Planet Labs Dove, is what it's called. It's a photo, it's got a photo lens on it. It's a picture taking satellite that is meant to be set up in a constellation. So there's 30 or 40 of these circling the Earth at all times. These little mini satellites are no bigger than a shoebox. So previous technology was telecommunication and picture taking satellites were huge, bigger than your car. Some of them big as houses. This technology really made it small. So if one had an issue, it wasn't expensive to change. So we've got satellites taking pictures of the Earth every day. And then in the middle, a few years ago, Case IH released a picture of their autonomous tractor concept. So this isn't full commercial release or anything like that yet, but it is being piloted mostly in the Midwest and overseas. And as you can see, this tech is basically just a tractor that they took the cab off of and decided to use. It's just completely run by a computer and outside sources of information. This one on the right, lower right, this is a FARMTECH Titan. This is a machine learning autonomous robot that crawls through lettuce fields and other specialty crop fields, mostly in California at this point. And it does mechanical weeding and mechanical disturbance of the soil to remove pests as well. It does have a small applicator on it for applying micro rates of fertilizer and herbicide, completely autonomous. So the idea here is instead of having to have an entire team of folks out there hand weeding or strictly chemical control, you're able to have a swarm of these small machines that go out there and handle this stuff 24 hours a day. Doesn't need to take a break. You don't need an HR department to take care of robots. It's really the next wave, kind of Star Wars-esque thinking. So that's kind of the evolution of field tech and where some of this stuff has been. Just a few examples, no endorsements by me, just a few examples of where we've been. So that's where we've been. This here is a slide that kind of explains a little bit of where we are today, the landscape of ag tech and field technology. So I compiled this list, talking to several sources that I have within my own company, folks that I work with, but then also I reached out to several other peers in the industry that work for other companies, folks that are in this space and where they see technology moving in the future. So we're stepping off of the farm gate with what we were kind of discussing with that last slide, and we're starting to think a little bit more about where we're at with the overall industry. So kind of think of it as your internal businesses, maybe your competitors' businesses, and just the status of the industry in general. So as we were doing this, we kind of decided on 5 buckets: supply chain, precision ag, artificial intelligence, robotics and automation, and genetics and biologicals. So we'll start with supply chain. RFID technology. This is nothing new, but if you think about our industry and the way that we handle some of our supply chains, our industry has barely adopted barcodes, let alone an RFID tag that could track a product from farm to table or through one of our own internal supply chains, through just warehouse distribution out to the field. Distributed ledger technology. I'm sure you guys have heard the buzzword blockchain, and it's really become super popular with Bitcoin. I'll touch on this one a little later, how we might find some ways that might get integrated into agriculture. Farm management software. So farm management software, I guess I've got to make a caveat. A lot of these line items could fit in multiple buckets because there's certainly plenty of precision ag components in farm management software. Shared economy. So there's a bunch of apps that are being developed to try to help in like sub-Saharan Africa and other emerging markets, small scale kind of boutique markets, some of the organic or very specifically grown crops where there's maybe special machinery or machinery costs and capital is a huge limiting factor for production. So the one example I've found was there's an app that's being used in Africa right now for helping basically share tractors and equipment. It's basically Uber for small tractor rental to help some of these emerging markets and these farmers that have been traditionally doing handwork, getting them machinery to more efficiently get their work done, and letting them share the cost or do a day rental on a machine rather than having to try to purchase one on their own. So then precision ag. Precision ag is kind of one of those things that we hear a lot of and can mean a lot of different things to different people. It can be anything from, auto steer in a tractor to a next generation, super intensive analytical script that's created to maximize nutrient use efficiency or input use efficiency. So hardware and sensors. The example I'll use a little later is FarmWise's Weed It machine. I think some guys have seen those around the country a little bit. They're kind of interesting. So increased imagery capabilities. That's some of your increased abilities with higher resolution satellite imagery, higher resolution fixed wing, pest detection from a fixed wing aircraft rather than a drone. And it also is drone technology. Artificial intelligence, the Internet of Things. So this is, probably the most common example for Internet of Things is the Nest thermostat for homes in large metropolitan areas, and how that internal sensor in everybody's home helps better resource and allocate the utilities company's ability to understand when and how they're going to need infrastructure and increase surges in their power grid. So Nest has kind of revolutionized that. One really good example for agriculture is soil moisture probes and weather stations that are interconnected. So you have a probe, which is the thing, but the thing is only as powerful as the internet source, and the ability to take that data and analyze it and make intelligent decisions with it. Robotics. So this is a big one. We'll touch a little bit later on the DOT farming system and 5G. So 5G is, as far as automation and robotics go, 5G fits all of these buckets. So 5G is going to be a huge game changer. I'm sure you guys have heard plenty about them and about what 5G is. It gives the ability for an observation from a sensor or a machine in the field to be connected at such a high bandwidth that it's able to send that information off to an offsite location, analyze the data, and then send back an instantaneous decision to that machine. So I liken it to the idea of that monitor in your combine or that monitor in your tractor. Rather than that being the computing device that has all of the hardware and all of the decision-making power is right there locked in that machine and it's stuck there. 5G connectivity would basically turn those screens into nothing more than a television screen. So it's not doing anything other than displaying information. But what that does is gives you the ability to take the information that is being generated and instantaneously send it off, run it through an algorithm or an analysis process, and then shoot it back to the machine to make instantaneous real-time decisions. And then genetics and biologicals. This is probably personally my weakest field, so I'm not going to talk about it a ton today. So those are kind of the landscape of technology. Certainly can seem a little overwhelming when you start digging into this stuff, but really the possibilities are endless if we start to look through what we can do with this. So thinking about all of those big ideas in those different categories and buckets, how is all of this technology getting developed? Who's playing in this space and what's going on there? So venture capital funding has been the huge driver for all of these startup companies and spin-off companies that have really started to change the landscape of agriculture and ag technology. There's a lot of buzzwords and there's really a lot of hype around some of this stuff, and the hype can really get overblown. But without this venture capital money and without that market functioning the way it is, there's a lot of products and a lot of processes that would be absent from the market. So here's just some trends in global funding for ag tech. And this is mostly venture capital money or even large companies that are in the industry that have a venture capital wing or have a division that is dedicated to spending money in the space to try to pick some winners. And it really is impressive to see how much money from 2015 to 2018 when it peaked, to see how much money has flooded into that space. 4.1 billion in 2018. As you'll see in 2020 here, just like a lot of other things, 2.6 billion was the target investment number as of August for 2020. And that's COVID right there. These venture capital firms, their risk assessments of a lot of these businesses completely changed when they were faced with COVID, and investors in general really kind of fled some of these high risk markets. I'm actually, when I saw this number, I was really quite surprised that it's as high as it is, because I read a note that said that they were figuring that this investment would probably finish out the year just north of 3 billion. So that for 2020, I would say that that's pretty impressive. And I would say I'm pretty bullish that investment is going to return right back up to that 4 billion level in 21, as long as we continue on track with getting things around COVID more under control. So that's the funding, and this is what the landscape looks like. This is put out by the Better Food Ventures organization. They kind of go through the marketplace and pick out who they think are exciting and different, maybe a leader amongst these different categories. As you can see, this is intentionally very busy. It shows how cluttered the space is. As a person in the industry that is approached by these companies all the time, and just like I'm sure a lot of you are, trying to weed through these and figure out what is effective and what actually means something and what is valuable to me. It takes a lot of time and a lot of resources to actually figure this stuff out, and a lot of trial and error. So what I would like to do next is we'll talk a little bit about some of the experiences I've had here in Montana, some of the things that have been successful, products and services that are offered out in the marketplace by lots of different organizations. And we'll check that next. Just take a quick little check-in, Danny. Everything loud and clear. And does anybody questions, please type them into the Q&A. All right, so what's working in Montana? So these are 4 things that I'm going to cover real quick to discuss to see what's been working, what have we found to be successful here over the last few years in Montana. So we're going to talk about layered satellite imagery, GIS reference soil testing, variable rate fertilizer and lime, and farm management software, more specifically profit mapping. So layered satellite imagery. These here are NDVI images taken over the course of a growing season. This particular field is a winter wheat field in central Montana. So NDVI images, I'm sure this is nothing new. You guys have all probably been bombarded with them for the last 5 years at least. And if you haven't, I guess the industry hasn't been doing its job. So NDVI, just to recap, is normalized difference vegetative index. It is a measure of greenness. So the green areas on the map are where there's a darker green, what we'd correlate to a more healthy biomass in the field. The red areas are less green. Some of them are all the way down to yellow. They're less healthy in the field. So layered satellite imagery. The idea here is you can see I've put the date that all of these images were captured here on each one of these images. The idea is to pair all of these layered images with a yield from this particular year as a sanity check, layer them on top of each other, and then run an algorithm that creates a normalized or equalized algorithm that will give you what the true variation in this field is. So most of these images, this one here is a Landsat image, but most of these are open source Sentinel images. These can be found anywhere, and there's lots of different softwares that can create this, and there's lots of different services and companies that you can call up to have these created. So once all those images are layered, this is what you end up with is for a final product. This is your an average production zone map. There's lots of different names for them, but that's a common one. And what it is, basically, if you knew this field, there's lots of topography changes. All these lower areas in Montana, our limiting factor is water. They're nice areas where water collects and we grow really healthy, robust crop. The red is either hilltops, or most of them are hilltops. Some of them are some funky things with some soil types, but most of them are hilltops that have been eroded down to limited topsoil. So those are, that's all satellite imagery. So you can't really talk about imagery without talking about UAV, drone technology. Fixed wing is another. So here's a couple things with drone imagery. Drones don't scale yet. Eventually they will get the technology right as far as the battery life and the payload capacities right, that you're able to utilize these more often. I know a lot of us have them. I've used one for the last 2 or 3 years for small scale things and have found it very effective. It just doesn't scale yet. It's not ready for every acre every year yet. And also there's some legislative things as far as line of sight rules with the FCC that we have to pay attention to, the FAA, to make sure that we are in compliance with making sure that we are not interfering with other users of the airspace, especially our colleagues in the aerial application business. One thing that is interesting is kind of halfway in between your drone imagery and your satellite imagery is there's been several offerings out in the market the last few years of fixed wing imagery that's become really powerful. You're able to put a really nice, big, robust sensor array on those small fixed wing aircraft, and they're really high quality images that are really effective and very, very usable. The issue with these is area of interest limitations. So if you're not already in an area where they're actively flying, it can be very expensive to try to attract them up to an area where they're not flying because they have to build out all the infrastructure to execute on flying the acres. Thinking forward, what we just talked about as far as our the layered satellite imagery, the next step in the process would be taking a layered satellite image and creating a GIS reference soil testing program. Okay, so here we go. We have our field. And what I'm going to talk about a little bit is a smart grid, because what I'm thinking about is the idea and some of the things that Clayne Jones talked about last week with our soil acidification issues and in Montana. And one of the most effective ways to deal with that is grid sampling. So small scale grid sampling is very expensive and very time consuming. We all know that there's a lot of growers out there that it's really hard to get them just convinced that soil testing is something they need to do. And I would say that soil test using especially a lime product without soil testing is an absolute waste of money, and you can actually hurt your field more than you can help it if you don't do it properly. So the idea is, here's our layered satellite image zone creation here that we have behind. And what we do is we overlay a grid on top of it. So each one of these grid points, it not only fits, a granular grid of some scale. Generally we go somewhere between 6 and 10 acres here for these large fields. So you've got the granularity of a grid, but then you also have the power of using that imagery to know what type of a production environment you're in when you get those soil test results back. So once you've created this, you go out, pull the images, you get the data back from the lab. That then gives you the ability to write the script. This right here, I just have this canned example of, this is a 40 rock script for a winter wheat plan. But this is where something, like the Fertilizer Institute, the 4 R's of Nutrient Stewardship Program, from FTI, that they've offered, there's different programs they have with trying to help cover the cost of some of these things for the growers and also for our businesses to try to help get things started. So if anybody's interested in that, contact somebody from the MABA board, and they can help you get started with the 4R Nutrient Stewardship Program. It's a nice way for us to maybe get in front of some of these things rather than always being on the back foot trying to come up with ideas on how to stay compliant. So, and from here you can write a Lime script or whatever else you would like, and there's tons of different softwares that you can do this with and tons of different service providers. So soil pH mapping. This is another interesting idea that's been out there. So Veris is nothing new. I'm sure you guys have all seen the Veris cart, so EC and Veris EC and several of the other companies that are out doing this right now. They've kind of taken it a leap forward with it. They've actually been able to put optical sensors and gamma radiation detecting units on some of these sensors that you take through the field, and they give you a heat map for where you have pH variation within the field. So it's really an interesting concept, and I think it's something that's very powerful long term. But the issue is it can be time consuming. Usually the best time to go out and collect this data to get the most robust data set is the time when you should be doing something else in that field, usually planting. And which is interesting because some of them have come up with sensors that you can actually put on your toolbar for when you're planting or if you're doing some sort of tillage. The other side of it is it needs to be verified with sampling. So it's kind of one of those things where you're maybe adding a little bit of work, but I think that the heat map can be a very robust and powerful tool. So farm management softwares. So there's a list as long as my arm of different farm management softwares and different products that are available out there. I'm gonna just run over one here real quick that is a little bit different, and there's several like this, but this concept I think is something that has been very powerful here to help growers understand their businesses a little better. So this particular one, you create scenarios, you line out different, you enter all your costs associated with your production. This looks like this is a chickpea plan. And so once you bring in your yield for the year, and you compare that with your costs, what this piece of software does, and there's a couple like it, it maps out your profitability by the acre. So what this is showing is, and it's the resolution's poor on these screen grabs, but what this is showing is that 20% of these acres, you're making somewhere between $0 and $25. And I think we'll see on the next slide, there's a 9% acreage opportunity. So that means that on 9% of these acres, with this cost structure, you're losing money. So every farmer knows this and every advisor knows this, that we have acres out there that we know we're putting money on that we are not going to be seeing a return. Or, we're having negative impact on those areas. We're just flushing our dollars. So what this does is it actually geo-references between yield and your cost and shows you exactly where in the field you can go out and maybe take a different approach, maybe do something a little different. So it's a pretty interesting concept. Examples of this in North Dakota, Western North Dakota, I heard from one of, I guess they're actually a competitor over there that was doing something similar to this. And they ended up helping a grower find a whole slew of acres and parts of different fields that he ended up turning back into CRP, because no matter what he did, he could never make any money on those particular acres. So doing this kind of deep analysis really is something that is, I think, really, truly important to help these growers move forward. And there's another piece of that as well, and I'll move into that here too. So I guess kind of my commentary on helping growers with these different ideas and different services is that a lot of these technologies that we have seen, and you saw that big slide with all the different companies out there doing all sorts of different things. The lion's share of these technologies are designed and spending their efforts trying to figure out how to use less inputs. So that's reducing the things that we sell, right? It's less seed, it's less fertilizer, it's less chemistry. So if technology is actively eroding our traditional markets, we as an industry need to find new ways to find access to the acres and access to the farm gate. And some of these different technologies, I think, offer, at the same time they take away, they do offer some ability for us to, move the ball forward in some other ways. So next I'm going to go into some examples from the ag tech landscape. I want you guys to know these views are my own. They're not WilburEllis's. And most of this stuff has been cultivated from talking to peers in the industry. These examples are not an endorsement for any product. I'm not trying to say go buy one of these or go talk to these guys. They're just products that I think are interesting and could potentially have a change or a fit in our market. So the first example I'm going to use is from supply chain, and it's going to be about just distributed ledger technology and blockchain. So I've got a short video here.
When you vote, have you ever wondered whether your ballot is actually counted? If you meet someone online, how do you know they're who they say they are? When you buy coffee that's labeled fair trade, what makes you so certain of its origin? To be sure, really sure, about any of those questions, you'd need a system where records could be stored, facts could be verified by anyone, and security is guaranteed. That way, no one could cheat the system by editing records, because everyone using the system would be watching. Systems like this are on the horizon, and the software that powers them is called a blockchain. Blockchains store information across a network of personal computers, making them not just decentralized, but distributed. This means no central company or person owns the system, yet everyone can use it and help run it. This is important because it means it's difficult for any one person to take down the network or corrupt it. The people who run the system use their computer to hold bundles of records submitted by others, known as blocks, in a chronological chain. The blockchain uses a form of math called cryptography to ensure that records can't be counterfeited or changed by anyone else. You've probably heard of the blockchain's first killer app, a form of digital cash called Bitcoin that you can send to anyone, even a complete stranger. Bitcoin is different from credit cards, PayPal, or other ways to send money because there isn't a bank or financial middleman involved. Instead, people from all over the world help move the digital money by validating others' Bitcoin transactions with their personal computers, earning a small fee in the process. Bitcoin uses the blockchain by tracking records of ownership over this digital cash, so only one person can be the owner at a time and the cash can't be spent twice, like counterfeit money in the physical world can. But Bitcoin is just the beginning for blockchains. In the future, blockchains that manage and verify online data could enable us to launch companies that are entirely run by algorithms, making self-driving cars safer, help us protect our online identities, and even track the billions of devices on the Internet of Things. These innovations will change our lives forever, and it's all just beginning. To learn more about the urgent future of the blockchain, please visit iftf.org/blockchainfutureslab.
Okay, so that's thought that was a nice, quick little animation on what blockchain is, or distributed ledger technology. So the examples I think that are pretty interesting for using these technologies in agriculture, the two that really stick out to me that I could see really affecting us, not only as producers, but as consumers. So the first one is traceability for our export markets. And I think about our pulse crops going to India and China. If we could have a secure distributed ledger backed token associated with each tender that went across the sea, it potentially, and not right away, but long term, it could be certainly something that could really help us maybe have less time for our shipments to be sitting in harbor getting vetted, or give some of the Chinese regulators less pause when they're looking through some of our product manifests. So I think there's certainly something interesting there, because the true power of blockchain is that it's completely transparent and it's a permanent record. So anytime there's a change, the change is recorded and you know who made the change. And it's distributed across all these personal computers across the world. And what's neat about that is if you've seen what happens in the world today when Amazon's AWS goes down or Microsoft Azure goes down. Those are large, huge server banks, entire cities built of servers that everybody stores all their information in one place on one platform. What this distributed ledger technology does is it spreads that risk out across the entire network, so you can't take out the information from one spot. So then the other one, the other example I think is pretty interesting as a consumer is for food safety recalls. If you have a completely open and transparent process and are able to track, say, lettuce from the field in Salinas, California, all the way through to, say Walmart in Miles City, Montana, and you know exactly every step along the way, and you can completely and truly verify that lot of product. If there was, say, an E. coli or salmonella outbreak in this example, you could execute a food recall with surgical precision. You would know exactly what went where, how, and when, and be able to remove just the affected product and not completely crash the entire market. So kind of an interesting application there for a buzzword like blockchain. I'm sure everybody's heard about it with Bitcoin. So next, in the precision ag bucket, hardwares and sensors, we're going to just show a quick little snippet of Weedit. I've heard of some of these being trialed here. This is another thing, for our industry to think about. It's one of those technologies that is designed to use less of the products that we traditionally sell. And it's really, it's an interesting concept because I feel that this is something that fits our fallow systems pretty well. So we'll go ahead and watch this little video real quick.
Weedit is the most accurate, fastest, and most easy to use weed detection and elimination technology available. By spraying only weeds, it helps you save up to 90% on chemical costs. 3 different application modes make sure the Weedit system is all you need. In spot spraying mode, it targets all living green material on fallow land. In dual mode, it applies a low application rate like 30 litres full width and a higher rate like 100 litres on every single weed detected. With in-crop spraying cover mode, Weedit acts as a normal sprayer but with pulse width modulation to vary the rate. Weedit fits onto every type of sprayer. Toolbars and trailed sprayers, quads, orchid sprayers, ground gliders, and self-propelled sprayers. We've learned that just one sensor every meter is sufficient to guarantee a 100% effect and to not influence the stability nor durability of your spray boom. Crucial at up to 25 km/h operating speeds. Each sensor is divided in 4 channels of 25 centimeters wide, which each control 1 solenoid and 1 PWM nozzle. Easy to install, robust cabling and electronics guarantee quick and foolproof spraying. Weedit only needs 2 components to work, 1 sensor every meter for detection and a PWM nozzle every 25 centimeters to ensure the correct rate is applied at the right place and time. Weedit eliminates weeds while taking into account driving speed, uneven fields and slopes, boom movements, and corners. The system adjusts for driving speed, boom height, boom movements, and boom speed. This way, Weedit always maintains the correct application rate even in irregular shaped fields. Besides, it has its own active light source for working night and day. Only Weedit corrects automatically and ultra fast for different soil and background conditions: dry, wet, shade. Eliminate weeds faster and more efficient with up to 90% lower chemical costs with the most easy to use weed elimination technology available. Weedit, precision spraying.
Okay, so I thought that was a pretty interesting technology. probably more of a grower technology immediately, but it could also become something that those of us that are in the custom application business, there could be a day that, we could have growers that are demanding technology like that be offered by their supplier. And, this company makes no bounds about it that, one of their major selling points is using less of the products that we sell. So it's one of those things that's on the horizon. And I think we need to maybe have some thoughts around how to move forward in this with some of these things. So the last one I'm going to use, and this is maybe more of a grower technology immediately as well. But when I think about this one, I think about how would industry interact with a grower that had this type of a product. So the DOT robotic farming system, it's kind of the idea of using swarm technology, utilizing multiple smaller autonomous machines rather than a 60, 80, 90, 100-foot drill and all the resources that go into running that. And like I mentioned before, with machines and robots, they do not require an HR department.
Agriculture is moving and evolving at an incredible pace. It's an exciting time to be a farmer, but a challenging one too. High machinery costs, lower value of trade-ins, shortage of skilled labor, and an increasing amount of hours in the field. Isn't it time farming was reimagined? Say hello to DOT, a diesel-powered, hydraulically driven platform set to revolutionize the future of farming. Collaborating with leading equipment manufacturers from around the globe, DOT integrates with any implement designed as DOT ready. The DOT Power Platform is a U shape. When it moves into position, the 4 lifting arms allow it to become one with the implement. The arms engage with the implement frame, and the hydraulic rams lift the implement. Once the implement reaches its resting position, dowels on DOT fit into holes in the frame of the implement. The unit is now ready to transport to the field and start working. The field can be mapped using satellite imagery or by driving the field to map obstacles such as sloughs, telephone poles, or tree lines, or a combination of the two. Once the map has been loaded, DOT uses GPS to travel the prescribed farmer-approved route to sub-inch accuracy. If an unmapped obstacle is encountered or DOT drifts from its path, it halts movement and sends a message to the operator. DOT has 4 independent, hydraulically driven wheels. The steering of each wheel is controlled by a hydraulic ram with an embedded, digitally controlled sensor. Whether in transport or field operating position, this system keeps DOT precisely online with the prescribed route map. If it varies from the path, the engine shuts down. When in the yard, DOT is operated with a remote. To increase safety even further, a second emergency stop remote can be activated to shut down the engine and all operations. Behind the stainless steel panels is the heart of DOT. The first panel contains 4 hydrostatic pumps, one for each individual wheel. The second compartment contains a 4.5-liter, 163 horsepower Tier 4 Cummins diesel engine that powers the hydrostatic drives and the rest of the system. The last 2 panels are screens to cover both the engine radiator and the oil cooling system. Designed by a farmer engineer with efficiency in mind, the DOT Power Platform will have a limited release in 2018 before being more widely launched in 2019. For more information or to sign up to receive the latest news on the DOT Power Platform, go to c.run.com or email info@c.run.com.
All right, so that was the DOT farming system. Pretty interesting concept. I guess the things that I think about when I think about that idea of all the things that it will take to serve and run that type of an operation. From a supply side, we're going to have to figure out what we can do to utilize that stuff, because those machines are going to be trained to automatically go refill themselves with the products that we sell. So there's a whole another question to be answered there. So that's all I have for you guys today. I hope I didn't go too far, confuse too many folks, but it's kind of a wide new world out there in ag tech, and there's lots of opportunities in the future. And I hope that you guys learn something and reach out if you want to discuss anything further. Questions, please, if anybody has any, I'd be really happy to discuss for a few minutes. And again, thank you, BASF and TeraxAF for sponsoring today's segment.
Thanks, Ryan. Is there any questions out there? I'm not seeing any, Ryan. I do want to thank you all for joining us for the Great Montana Ag Rally, and we hope you found this session to be informative and helpful. Thanks to Ryan Helmer and to BASF for their support of MABA. The next session of the Great Montana Ag Rally will begin at 10:30 today, and we will cover problems in chem fallow, and that is covered by Dr. Phil Westra of Colorado State University. If you're not registered for that, again, just go to our website, www.montanaagbiz.org, and register there. Hope to see you there, and if not, Merry Christmas and drive safe. Thank you, everybody.